Okay, we are COMP123 and it's week 3, lesson 3, part 2. And what we're going to be doing now is the next piece for using classes and objects. I'm just going to connect now, just in the interim, to GitHub. I'm going to go to Home under my Team Explorer. I'm going to go to Changes. I'm going to look at untracked files and add them all as well. And in here, don't have to do this, you just have to watch. I'm just going to create course files. Commit. And in there, I'm going to go into unsync commits. And inside my unsync commits, I'm going to take my URI from my repository, which I'm going to show you how to do next day probably, and copy and paste. I'm going to publish the branch, and when I go back up to GitHub, you guys have what I have. Right? Here's my stuff, car and my program. It's up on GitHub under my name. Okay. Let us continue. So we've got a couple things here. We don't have a constructor. We've talked about properties and methods and all that kind of stuff. Let's go back. So again, we have so far we've created properties, and I made a set speed method, but actually there's a better way to do it with properties, because remember, we want to make all properties for proper data hiding or for correct object-oriented methodology. All properties, unless required, should be private. Let's just think of that. So how do I access them? Well, there's something called setters and getters, right? This is back in the day, we used to call them setters and getters. Here in C# we call them set accessors and get accessors. So two different methodologies for accessing data from a private property, right? Otherwise, all properties, by good methodology, proper object-oriented methodology, should be hidden or private. So there's two ways to do it. If I set a setter and a getter, right, a set accessor and a get accessor, we're going to show you how to do that in a second. That means I can read and write to the property through these accessor methods, right? If I only have a get accessor, then I have a read-only property. So if I want to make the property accessible so I can read it, but I only create a getter, a get accessor method, I'm using the same word, just different ways, right? Then it's read-only. I can't write to it. Like for example, in my car class example, if I want to know what the color of my car is, I should be able to get the color, but I shouldn't be able to set it by going mycar.color is equal to blah blah blah. That's wrong from an object-oriented methodology perspective. Not that you shouldn't do that at times, but in this particular case, it doesn't make any sense. So here's what a get accessor and a set accessor would look like. You have my public ID number, and my ID number is a public method or property, right? It's a public property, but I have a get inside of my. It's almost like I create a little code block for my property. So my property is called ID number. Imagine my property is called color, right? But I can create a little code block for the color, and I can use a get method, which is a built-in method, and a set method to get or set the value of the property. Whew, this is a kind of a difficult concept. Some people, especially new students who've never seen object-oriented programming before, they're like, why? Why do I need to do this? Why don't I just go, you know, the name mycar.ID number or mycar.color is equal to. Again, we're going back to the best practices. Object-oriented methodology tells us we need some kind of interface to connect with our class, right? And we use getters and setters, get accessor methods, sorry, and set accessor methods in order for us to set and get the values of properties of a class. So there, if we wanted to do the same thing in our little example, right? I've got my make, model, and color. And let's say, for example, I want to set my make. I can right-click, and I can go to refactor, right, as an example. And if I say encapsulate field, right, and if I say, for example, make, right, just follow me for a second, don't do it. right? Update references external, right? And it says preview reference changes. I'm going to do that, and I press OK. What it's going to do, if I encapsulate it, here's what it looks like: public string make, right? This is what the preview is going to look like. All right. Actually, this doesn't do what I want it to do. It doesn't do what I want. It should actually show me my getters and setters. Let me try that again. Usually refactoring does that. If I go extract method, right, like we did last time, it actually does it for me. And I'm guessing, I'm telling you right now. And here's the extract the interface. Let's see if it does that. No, that's not what I want. Definitely not. So we have to write it ourselves, unfortunately, in this version, right? Usually we're allowed to. I can totally extract a method or encapsulate a field. And when I do that, in other case, what it does is it allows me to create my getters and setters. But if I just want to create my getters and setters anyway, here's my public string object. I need to create a little code block for it. So here's my public string. And inside there, I can use my different keywords, right? So again, if I go back to my example, if you notice, get is the first keyword, and then set, right? Get and then set. So I can do the same thing with my my property here. The only difference is this: the getter method or the getAccessor method requires the return keyword, so I can return, just like any method, back the value that I'm returning back to the person that's calling it, and then I use this value keyword to get the value that's put into the setter for me to take that value into the property. Whew, I know, confusing. Let's try it. So get, and when I do get, I need to have this is its own little code block, right? And I need to have a return. That's the first thing you need, okay? I was hoping to have a little thing in there as well, right? And then for set, here's my code block. I need to assign a value, right? So again, what I want to do is return the make. That's what I want to do. So that satisfies my get. So I take my make property, right, and I want to return it. And when I do have my setter, right, I want to set my make property. So make is equal to value. And value here being a keyword, not a variable, right? Value means I'm taking the value from what I use from a make and putting in there. If you notice, it says field is never assigned to and will always have its default value null, right? Because I haven't set a default value for make. It's just a warning. Okay, I've saved it, and now if I go back out, if I go back out to program, I'll be right with you. If I go back up to program here, and if I go my car, right, now if you get the code hinting, you'll get this. If you don't get the code hinting, you won't, right? If I go my car dot, right, and if I go make, look, make has a little wrench next to it, right? It doesn't have the little blue dot here, right? The little wrench means it has a setter or a getter. In this case, I have both. So if I go make, now if I open it, it says nothing. It means if I leave it like this, right, and I put a semicolon in there, it's going to return, right, the make, but it's returning something somewhere else. I have to take that make in there somewhere. So maybe I can create a variable right now, just a temporary variable called, I'll make it a string, right, and I'll call it my make. Let's just say for now, right, and I can assign it my make, my make is equal to my car.make. Now, why is it giving me an error? It says non-invocable member cannot be used like a method, right? Well, why? Because I have these brackets, right? If I take away the brackets, now I'm accessing the getter. See? String, car, make. It's the same way as I would use a property, right? However, and that's going to go back to here. That's going to take the make of the car and assign it. I'm getting it. That's my getter, right? I'm getting it back, and I'm putting it into this string called my make. Okay, I'm just making this up, by the way. But if I want to set it, I don't need this, right? I don't need this at all. If I want to set the make of the car, then I can use the same word, make, but I put it in brackets. Make, in brackets, Honda. And it accepts a string. And if I put a semicolon, right? That's not right. Let's try that again. Make is equal to Honda, right? That's right. Getter and a setter, right? My car dot make is equal to Honda. It's exactly how it would be. Exactly how it would be here. I'm going to save this. Is if I didn't have this getter and setter. In fact, the getter and setter is automatic if you don't set it. If you don't set this up, if I don't put this in there for each property, the getter and the setter are written for you in the background, right? So if I was just to say something like, just like I normally would, right? My car dot make is equal to blah blah, right? It's the same. Question, sorry, before I go on.
I think it answers itself, but basically the value will recognize any data type. Okay.
But it's not supposed to. It's only supposed to be string, right? Or else if you come in there, you have to check it here. You could check it inside the setter to check to see that the value is of the string type, and if it's not, you should error out. Say only you can only set it a string type variable. You should return something to the user or create an error, right? We'll talk about that later. But for now, it does accept anything. But so will it anyway. It would have anyway. Like for example, here's a couple more. Model and color. We don't have getters and setters for them. But if I go to program, right, and if I say my car dot model, it's there, right? And my model is a pilot, right? It'll accept that. But if I also put down something like this, if I put down 1, it'll accept that too, right? It's wrong, and then it'll give me an error saying, hold on, my model should be, it's a 32-bit signed integer, but I don't need that. I need it to be a string, right? Whereas here, car make, if I go 1 for car make, does it error out? It does, right? Because it's expecting a string as well. It's the same, is what I'm saying. Although you should physically check these for validation. So again, I've used it 2 different ways. Model without using getters and setters, and make, right? I have getters and setters for make, get accessor, and set accessor. The difference here is if I take away the set accessor method, right? If I take this away, I'm going to put it into kind of a code block here. I'm going to take this out here. I'm going to kind of go put it in there for now, right? So I have a setter. I'm just putting it into a. I'm putting it into a. And of course, I also put this one in here, which is wrong. I shouldn't do that. I meant to do this, right? So this is inside comments, right? So it's kind of in deep freeze right now, right? It's there, but it's in deep freeze. It's in the winter garden, and I'm going to take it out later on, right? But right now, it's when I have it inside this this comment block, right? It's not accessible. So now I only have a getter. Oh, now there's a problem. Now if I go back to my program and I said my car.make is equal to Honda, it says, wait a minute, error, property or indexer, right, cannot be assigned to. It is read only. So here's a good way of making a read-only property. I can't write to the property, but I can read the property. It's a way of protecting my data. So I can get the data with a get accessor method, but I can't set the data, right? Again, I'm protecting my data here. And all I've done here is take away the setter. Yes?
Here we haven't assigned any values, or how can we get something?
There's nothing to get,
Yeah.
right?
Thank you.
But again, we're going to assign the value through our constructor, which is the right way to do it, right? I recommend it, actually, right? But for now, you don't have to use the getter and setter if you want access to both read and write a public property, right? If you want to do only reading from a public property, this is where you use a getter. Typically, we can also do write only. If I only use a setter, more rare, it's more rare, but I could only set a setter up. That means I can only write to it, but I can't read from it, which is kind of weird, right? Usually if we can write to it, I should be able to read from it, right? But you could do that in some cases. I don't know why you'd want to do such a thing, right? But the idea here is that even though these things are properties, and in other cases, up until today, right? Sorry, just keeping track of time. Up until today, we've been able to access a property. We can create a property, and we can set a value for a property, right? Any property, an integer, a string, whatever. Today, I'm telling you, you can break this property down and create its own code block and create its getter method, or getter accessor method, and set accessor method, right? Doesn't mean you have to, but you can. And the reason why we do is to, again, support this whole idea of information hiding with object-oriented programming. Let's go back. So we've done this piece. And again, I'm not going to cover this for now. I'm going to go back to that. I want to keep it simple. That's why I'm skipping by some of these other little things that are said here. And again, if I don't cover it, if I say that it's, as an example, if I'm not covering here in class, and if I don't test you in class, like maybe I won't give you the test today. I'll give it to you tomorrow for those people who come in. I'll do that little, stuff today, tomorrow, right? But no real test. I'm talking about the little poll we'll do tomorrow, right? But when I do that, it'll give you some examples, 3 to 6 different question examples for this chapter test that we're going to do, right? Okay, here's an example here. Here's another one. So I'm creating some properties, right? Here's my static void main, which is my main program. And here's my employee example again, with my chef being a new employee. I'm actually giving him his number, his employee number of 2345, right? And then I'm taking that number and using it in a write line statement, just like I normally would any property. But I have to use the dot accessor or dot notation, this dot notation here, to access the ID number of the my chef object. I've created a new object, a new custom object, and the only way I can access it through the dot notation method, right? Just like we see any other custom or any other built-in objects that we see already. We've already used. Okay. Again, like it says here, they're auto-implemented, right? So even though we don't use the setter and the getter, they're already there in the background. C# actually, when it's compiled, it includes auto-generated or auto-implemented properties for each property. Each property has a setter and a getter. Unless you specifically define them, though, you can both read and write to it, right? That's all it is. That's what an auto-implemented property is. So if you see that on the test, that's what it means, right? For those people who are watching the video. And here's an example of that, right? Because all we're doing is doing the same thing with salary and ID number. I've already shown you this, right? But again, it doesn't support information hiding in the same way. So again, more about public and private. We can also call something a static, right? A static variable if it's a named constant, all right? And again, this static is something that's available to the entire class, right? That means it can be accessed, right? As an example, from other objects. This is kind of weird. And this is what I don't agree with so much. An example of this would be high score. If I had multiple players, each player is an object. So I have, Tom, John, Mike, and Stan, right? And each of them is an object instantiated from the player class, right? And they have their own properties. But let's say I have a high score object that's part of the blueprint, the class player, right? Well, if I can actually store a high score, so I can use the blueprint class as a container class and store my high score inside the class, even though I haven't instantiated it. And guess what? That high score is going to be available to each object that's made from that class. So if I say something like Tom.highscore, Mike.highscore, John.highscore, it'll be the same number across all of them, right? I don't think it's a great way of using it. That's why I don't like static variables or properties or methods, unless you're using the whole class as a container class, right? I try and separate those two around. Everyone's different though, so from a programming methodology, it makes it easier for my brain to do that kind of thing. So I make a class, Example would be, I'm creating assets for a video game. I make an asset manager class. Well, my asset manager class is going to go hold all the assets from my video game, my images, my sounds, and blah, blah, right? I don't have to instantiate that class. It's just a container class, which I can grab the assets from when I want to, right? It's available to my entire code. That makes sense to me. Making a static variable that's available to all the other members, there's got to be a real reason for that, right? Some kind of value that's passed along to each member, right? And here's a long example of getters and setters inside your PowerPoint presentation here that shows you how to create getters and setters for different properties, length, width, and area, right? And in this particular case, we have a constant called string that has our motto, our carpets are quality made, that you can't change, right? So I can always access this constant. Not a great example. And in this particular case, this is the main program, and I'm accessing the width, the length, and all this kind of stuff outside of it. One of the things that makes us, use object-oriented programming across different languages is that every language has its restrictions when it comes to accessing its properties within each class itself, right? So right now in my current example, right? And by the way, I'm just going to kill some of this stuff. I don't need any of this, right? I'm going to actually just add a semicolon for now, right? And put it back the way it was. We're going to make them private in a second, and you'll see why, right? So here's my make, my model, my color. But if you notice, I'm accessing my speed way down here, right? Now, here's a question. Should I have access to speed, right? This speed variable, which is a class variable, right? In every method. And the answer is yes, you should. Some people would say yes, you should, but different languages would stop that from happening. Here's an example. Even though this speed is private, it's available to every class member, or all members within my class. That means it's available to all methods and other property variables, other properties within each member, right? In other languages, I wouldn't be able to do this. This speed here, I couldn't do it, right? The reason why is because we don't know what this speed is. What if I, inside this set speed method, I created a new speed called speed, right? And I say my speed is equal to 10, right? Or my speed is nothing right now. And I set the speed, my new speed incoming. This is also correct, right? But I've just declared a new variable called speed, right? Which speed am I talking about? The speed that's in here or the speed that's out there? How does the compiler know, right? And what if I want to set one speed to the other? Like this, right? Down here I want to say speed, right, is equal to speed, right? But I mean this speed up here, right? Not the one down here, right? Well, there's no way to do it without a keyword. And we use the this keyword to devise that. So example would be this. And sorry for my usage of this keyword. In some languages it's called self. You might see that as well. But what it refers to is the instance variable that I'm talking about. When I use the this keyword, it's like I'm telling the compiler to use the instance variable, not the local variable. So I can have the same name, right? But I don't want the same name. Typically it's bad programming practice, but sometimes you have no choice, right? Or it makes sense to use the same word. So what I really mean is this dot speed is equal to new speed, right? That's what I really mean. I mean this speed here up here, the speed that's part of my class, my instance variable speed. So I can use the this keyword to be specific. Now if you notice, see how this speed here, the local speed variable, isn't being used, right? Because I'm not accessing that speed. This is a local variable, this speed here, where it just says speed, is only accessible in this code block, right? And this code block down here in the set speed method. But this speed here, when I put the this keyword, is referring, it's a reference to the speed variable or the instance variable that's in for my class, right? So whenever I use the this keyword, it refers to the class variable. Similarly, I can use the this keyword for methods, right? So I can go this dot set speed, right? Because sometimes I might have overridden a method, right, that I've used somewhere else. So if I want to make sure that the compiler knows which method and which variable I want to point to, I use the this keyword. This, right? All it's saying is it means the method or property that belongs to this class. That's all it means. The local method or the local property, the class variable in this particular case, and the class method. Because I may have another method called setSpeed. I don't want that one. I want this one. And that's how I can reference it. I can point to it. It's almost like a pointer. In C++, it would be a pointer to this method. That's what it would be. Where this comes into play is when I use my constructor, which I'll show you in later on. If I run this thing, if you notice, I've cleared this variable, and if I run it now, I should be able to do this with impunity. It shouldn't give me an error, right? See, it works. Even though I'm using, it's the same thing. This speed is equal to new speed is the same as saying speed is equal to new speed because I haven't defined a local variable called speed within this context, right? In this context right here. Okay, I haven't defined a local variable here. So it would be okay to use speed is equal to new speed, right? But the proper way to do it, and I recommend highly that you always do it, is use this dot speed to indicate that you're accessing the instance variable, the class variable. I know it's confusing, but we'll take it up again next class to make it clear as mud. Here's an example of this, right? Where I have a bunch of variables here, private, static, private string. I have some private variables here, and I want to access them, right? This is inside my book class, right? But this is what I really should be doing. This dot title, this dot title, this dot title. And all it's doing is saying, I want this one. I don't want another local one or some other title. I want the title that's inside the instance variable title. So it specifically points to that, so there's less chance for error or ambiguity, right? And that's why we do it. When you see this variable for the first time, you're like, what the hell is that? What does it mean? Why do I need this in the first place? That's all it is. It's just a pointer or a reference to the variable, the instance property or whatever, or the class variable, however you want to call it, or the field that belongs to the class. And that's what it's a specific pointer. It's almost like there's a line that goes from here to here, right? To where it says the title, here, right? From here to here, from here to here. It's like a line. It's pointing. It says that one, not another one, not another kind of title, this one. And that's why we use the this keyword. Again, other language, you'll see self as the keyword. It's the same thing. Self, this, it's the same. And many C-influenced languages, you'll have the this keyword. And that's what it is. I'm not going to go through all of it. So, and this is the difference. So here is where we start using the, I have a public method, right, called set price and tax. And I have the same word, price, as a double. It's instantiated as a double, right? Well, guess what? This price here, this is the parameter that's incoming, right? It's called price as well. But so is my price that's inside of my book class. So if I want to tell C# which price I'm talking about, not the price that's incoming, the value that's incoming here, but this one that's pointing to this class here, I need to use the this keyword. Do you understand? Yes?
Without the this, is it always pointing to the local variable?
Yes. It always points to the local variable. If the local variable is not defined, then it hunts for the nearest one, which is the class variable. Why would you want your program to hunt? We don't want your program to hunt to find stuff. You should tell it what to do, right? We're programmers. We're logic, right? So we use this variable. I want you to get into the habit of using this variable all the time. right? So you point to it all the time. So there's no ambiguity. There's no question as to what you're pointing to. Some books will say, you don't need it. Don't use it if you don't need it. I'm telling you, use it all the time. Okay? You'll never get into trouble this way. We're going to stop here. I'm going to cover constructors next class, which is tomorrow morning, bright and early at 8:30, right? We're going to stop the thing right here because constructors are really an important part of object-oriented programming. Again, if I have to extend this lesson for one more class, I don't care, as long as we get this right. Let me just go back and stop, and then I'll field questions.